Hello, everybody, and welcome to our SAMHE webinar. We are absolutely delighted to have you watching along with us live, and also for those of you who are watching this as a recording, welcome too. Today we are going to talk to you about the findings from the SAMHE results so far. We're going to be talking about how many schools have engaged with the project, how we are using your data, and what we've learned about school and classroom indoor air quality. And most importantly, we want to thank you for being involved with SAMHE. So who has been involved with SAMHE? Well, we have recruited 1,321 schools. 885 schools have sent us data, and 742 monitors are still sending us data. So what have we done together? So schools have received and set up their SAMHE monitor. The SAMHE team have developed a web app, which we co-designed with some of our pioneer schools. And we've set up activities on the SAMHE web app for you to take part in. Pupils have completed fun activities, they've learned about air quality and inputted really important contextual data, which helps our researchers understand where your monitor is in your school. And the data that's been received by the SAMHE scientists has been analysed so that we can report on air quality in classrooms. So how have we used that data that is coming from your SAMHE monitors? So in order to better understand the air quality in your schools, we have spent lots of time examining the data that your monitors record and combining that data with data from all sorts of other places, including data about the weather and lots of other things about the school environment. So now I'm going to hand over to Sam and Alice, who are going to be telling us what we've learned about what affects ventilation rates and what affects particulate matter in classrooms. And I'm going to stay on and I'm going to be pressing the next button when Sam and Alice tell me to. So over to you, Sam.
Hi, I'm Sam Wood. I've been researching ventilation in schools, looking at what we've learned from the SAMHE project. So I'm just going to start by talking about what is ventilation and why it's so important. Ventilation is the process of refreshing indoor air by letting fresh air in and removing stale air. Ventilation helps us maintain good air quality in indoor spaces by diluting and removing pollutants from the air. So good ventilation reduces the risk of airborne illness like COVID-19, and it's also been linked to better concentration in schools and just helps create a better learning environment. Next slide, please. So people give off carbon dioxide when they breathe, and this carbon dioxide is removed by ventilation. The number of people in a room, their age, their activities, all affect the amount of carbon dioxide they produce. This is quite useful for SAMHE because we can't measure ventilation directly, but we can measure carbon dioxide. So we can estimate ventilation rates from the level of carbon dioxide that we measure on your SAMHE monitor. Next slide, please. So most SAMHE classrooms use windows as the main way to provide ventilation. People open windows more when it's warm, so ventilation rates are closely linked to outdoor temperatures. We started by looking at outdoor temperatures across the UK over last autumn school term, which was the first full term of SAMHE data. And we want to know, what does this tell us about ventilation in UK schools? Next slide, please. This graph is going to show the outdoor temperature averaged across the UK in the period that we investigated. So there were 4 distinct weather periods over this time. Initially, we saw a period of warm weather, highlighted in pink, going up to half term. And then after this, we saw a period of sort of medium temperature, which I've coloured in yellow. Then there was a colder period, coloured in blue, followed by another medium temperature period. So we want to look and see how ventilation in schools was different in these different weather periods. Please. So in order to do that, we're going to look at carbon dioxide levels averaged across all SAMHE classrooms during the same time period. So we're looking at the same weather periods overlaid on top, but this plot is showing temperature rather than, this plot is showing carbon dioxide levels rather than temperature. So firstly, we can see that the carbon dioxide levels are quite a lot lower during the warm period than in the other periods, and a fair bit higher during the cold periods. And during these sort of medium temperature periods, classroom carbon dioxide levels sit somewhere in between. So we can see that SAMHE carbon dioxide levels are relatively dependent on the outdoor temperature. And what this means is that when it's cold outside, ventilation tends to be poor as people close their windows. But this varies quite a lot from school to school. So in the cold period, many SAMHE monitors also measured carbon dioxide levels higher than the government guideline. So this government guideline is shown in the red dashed line. Next slide, please. So we've seen that weather plays a big role in classroom ventilation rates. We also looked at other school-wide factors using various other data sources to see what else might affect ventilation. And we found that schools showed similar carbon dioxide levels, whether they were in cities or near the countryside. We found that secondary schools generally showed higher carbon dioxide levels than primary schools. We sort of expect this because we know that children breathe out more carbon dioxide as they grow older, so we'll measure more of it. And also, schools have a target level of how many pupils they should have. Schools with more pupils than this generally showed higher carbon dioxide levels than those which didn't. Next, please. So what can schools do to improve their ventilation levels? Well, you can use your SAMHE monitor to keep an eye on ventilation by checking the CO2 levels. This is particularly important in colder weather because, as we've seen, people tend to open their windows less and ventilation tends to be poorer. So teachers and pupils can try to remember to open windows more when it's cold outside. You can also think about opening the windows wider during break times to better ventilate the classroom in between lessons. And SAMHE will be continuing to monitor school air quality, and we're going to look to find out what else we can learn. But we're also working with government, unions, school leaders, anyone that has some power to influence the classroom environment, and we'll be using your SAMHE data as evidence. I'll now pass to Alice, who's going to talk a bit about particulate matter in classrooms.
Thank you, Sam. So alongside carbon dioxide, your SAMHE monitor also measures particulate matter. Particulate matter describes the mixture of solid particles and liquid droplets in the air, and you may have seen it abbreviated to PM. There are many different sources of particulate matter in indoor air. So some come from outside, such as those generated by traffic, and some are generated inside, such as due to cooking or dust resuspended from the carpet during cleaning activities, for example. Particulate matter is often classified by its size. So the picture on the right shows a human hair in grey and compares different particulate matter to the width of a human hair. So on the largest end of the spectrum of PM, we have fine beach sand. And then if we next look at the blue dots, we can see the size of PM10 relative to a human hair. And PM10 describes particulate matter that has a diameter less than 10 micrometers. Next, Sarah. What we're going to focus on is PM2.5. So within each of these blue dots or blue balls that we can fit many of these red balls. And PM2.5 is particulate matter with a diameter of 2.5 micrometers or less. We're particularly interested in PM2.5 as these are very fine particles that can be breathed into the body. And we know that these small particles can affect health, especially for children. So next slide, please. So just like we did for CO2, we're going to look at the particulate matter from the autumn term of this academic year. In the map on the right, every blue dot shows a SAMHE school. So some of the SAMHE schools whose data we're going to look at today. As some sources of PM come from outdoors, we're also going to compare particulate matter in SAMHE classrooms to the levels in outdoor air. The government runs weather stations that are near your schools, and each of the green dots shows where these weather stations we're looking at are. Next slide, please. Here is plotted the concentration of particulate matter outdoors against time over the term. The blue is the daily mean concentration averaged over the weather stations, and we can see as it rises, the line rises and falls as the level of PM in the outdoor air increases and decreases. Next, we'll look at the schools, SAMHE schools, particulate matter. So the red line shows the daily mean concentration averaged across all schools in the study. We can see that, like with the blue line, as the red line rises and falls, the level of particulate matter in SAMHE schools also increases and decreases. Some of the key things we can see from this plot are that the outdoor concentration is nearly always higher than the SAMHE schools concentration. The indoor concentration, or the SAMHE schools concentration, is very closely linked to the outdoor levels. In particular, when there are peaks in school PM levels, this is usually at the same time as peaks in outdoor levels. We tend to think of particulate matter sources outdoors as locally generated, so it's quite an interesting result for us to see that these trends, which are across nationally averaged across SAMHE schools and across weather stations, there's an interesting trend between the indoor and outdoor. The World Health Organization gives guidelines on air quality and recommends that 50 micrograms per meter cube should not be exceeded for a daily mean value. And that's the black line plotted across the screen. So if we go to the next slide, we can see, we can investigate a time when this value was exceeded. So next. In September of last year, some Saharan dust was blown from Africa up to the UK and over Europe, and that's what this satellite image is showing. The next image is showing red sunsets. So you may remember in September that the sunsets were particularly red compared to normal, and this is due to Saharan dust in the air. And finally, you may remember that Saharan dust settled, so most notably on cars, which is the bottom image. The yellow band shows when in the term time this happened, so in September. Next, Sarah. We can see that because the red line and blue line are very high, not only did Saharan dust come to the outdoor air in the UK, it also made its way into SAMHE classrooms. It's quite interesting to see that weather events and things that happen in Africa can affect what happens in our SAMHE classrooms. Next, Sarah. It's worth noting, though, that this period also coincided with the start of school term in England and Wales. So it is possible that some of the dust that settled out of the air over the summer holidays might have been brought back into the air and stirred up from the surfaces and the carpets when people came back to school, which might be why the indoor or the particulate matter levels recorded by SAMHE monitors is so high as well. Next slide, please. So the Saharan dust event that we just looked at affected the entire nation, but other things happen that generate particulate matter a bit more locally to schools. And one of these is fireworks. So in autumn, there are two big events that use fireworks to celebrate, and that is fireworks and Diwali. So next two, I think, Sarah. We've noted on the plot when these occurred. So you can see that the blue line and the red line increase over these weekends. It's interesting that the PM levels increase in schools, especially because fireworks are typically set off in the evening and over weekends. So although windows are probably closed in schools, some particulate matter is getting in. But let's look at data from just school hours only. So if we go to the next slide, we can see this is data plotted considering only the hours of 9 till 4 weekdays and excluding holidays. So if we click 2, we can see we've blanked out half term and Christmas. So fireworks night, if you click one more, Sarah, occurred just at the end of half term, and Diwali occurred the weekend after. What's really interesting to see is that although the PM levels had increased in schools, when we only consider the hours you're at school, by the time you come back to school on Monday, if you click next, Sarah, we see that the particulate matter levels have decreased, which is very interesting. So if we go to the next slide, I think we can just think about what we've learned about PM so far. So outdoor events that are both seen nationally and very locally to schools can affect the classroom particulate matter levels recorded by SAMHE monitors. One of these large events that we've looked at is the Saharan dust storm. And so pollutants can be blown from Europe and Africa and other places in the UK to our schools. Other small events also can increase particulate matter levels in classrooms. And it was interesting to see that whilst fireworks over fireworks night and Diwali increased the particulate matter levels, by the time school starts on Monday, they had reduced in classrooms. So what can we do about it? So if we go to the next slide. In schools, you can use your SAMHE monitor to check on the particulate matter levels in your classroom. And it would be really interesting to take note of why those levels might rise. Is it due to particular activities? So potentially arts or DT activities, or maybe activities in science rooms, or potentially if you're doing cooking, or if you're using chalk and that generates chalk dust. And if you do notice these activities generating higher levels of particulate matter on your SAMHE monitor during class time, it'd be really advisable to open windows to ventilate the air. There may be other activities that happen in your school that could be scheduled outside of school hours. So these might include maintenance and cleaning, and by scheduling them outside school hours, it will hopefully keep the levels of particulate matter during school hours lower. Us as the SAMHE team are continuing to collect results and communicate what we find to government and local authorities to really identify ways in which particulate matter can be reduced in classrooms. So I'm going to hand back to Sarah.
Brilliant, thanks, Alice. So just before we go into your kind of questions, which we're really excited to hear, we're just going to give some conclusions and then tell you where you can find more information. So what Alice and Sam's results have shown is that classroom ventilation rates change with outdoor temperature, but also depend on other school factors, such as how many people are in your classroom, and whether you're in, and how big your classroom is and things like that. Also shown that classroom particulate matter concentrations are really closely linked to outdoor particulate matter concentration. So these are some really helpful results that we've got coming from the data that your monitors are sending us. And we will learn more as we get more data. So please keep your SAMHE monitors connected, including over the holidays coming up, because that means that we get to see data about what happens when you're not in your classrooms, but also means that when you come back after the summer holidays, you'll have a really nice big data set that you can have a play with on the SAMHE Web App. So if you found that interesting, there's so much more that you can read about this work on the SAMHE Outputs page. And I think Victoria is going to pop the link into the chat screen so you can go and explore at your leisure. So there's things like a technical report on the Sahara dust event that Alice has just talked about, and fireworks, termly analysis of the data set. And then there's also links to the academic papers, which are things that we write for other researchers that you can read as well. So we're now going to move into the most exciting for us bit of the webinar, which is the question and answer session. So if I could invite all of our lovely panelists to unmute themselves and put their videos back on, and I will stop sharing my slides. So what we'd like you to do is to put your questions into the Q&A function at the bottom of your screen. If you can ask them anonymously, that's great. If you want me to read out the name of your school, then that's great too. So if you wanted to say, for example, St Mary's have a question about ventilation or whatever, then you could type the name of your school into your question. So we will get ourselves started. Thank you, everybody, for the questions that have come in so far. So we have a question here, which is, how do you recommend that we make best use of our SAMHE monitor? That's a wide-ranging question, isn't it? Who wants to start with that one?
Me, Henry, please. So I think I would sort of think of its usage really broadly in two ways. One, you can use the monitor as a tool to help you manage your classroom ventilation level. So there's, you know, the data in terms of numbers is actually written on the screen in the monitor, or you can use the numbers of lights and their colors to help guide you as to when you might want to open your classroom windows a little bit wider. And equally, you know, if your classroom is really cold and your lights are green, then you can think about whether you reduce that and keep the children a bit warmer. And then I think the other, I think more unique thing about the SAMHE provision is the usage of the monitor via the web app. So in the web app, we provide you an enormous range of tools to examine your data in different ways. And this doesn't have to be done in a guided way. You can provide your pupils access, and they can explore the data very graphically, and we have visualizations for a wide range of age groups. And then there's all of the activities, and they're very wide ranging and cover lots of stuff linked to the curriculum, so they can even play a role within your teaching. And all of this can be sort of explored as classes or small groups, perhaps in science clubs, or
loads of options, aren't there? Loads of options.
Yes.
Thanks, Henry. So we have another question here, which is, do schools need better insulation to protect from outdoor particulates occurring during school closure times? Alice, do you want to start off with this one?
I would say that the key takeaway is that levels of particulate matter seem to reduce by the time you get back to school. So that seems to be fairly reassuring, that although things that happen during the night and over the weekend could increase levels, then by the time things have people come back to school, it doesn't seem to be a problem. There's a balance, I suppose, between checking that windows are closed and also providing enough ventilation to schools. So it might depend on the leakiness of the building, but I think that generally they're not at levels that we're concerned about. And ventilation is one of the key ways which we can improve indoor air. So closing windows closing windows for security reasons is kind of usually done, but closing windows during the day, if worried about particulate matter, I think generally we'd favour more ventilation to refresh indoor air. I don't know if anyone has a more input on that.
I think that was a great answer. Thanks, Alice. I'm not seeing any of the other panelists jump to answer. So another question we have from Ruth Bexley Grammar is is around the types of activities that might be good ones to do within the SAMHE Web App. And I don't know whether Lucy, who you may have been communicating with via email at the end of our hello@SAMHE email address, if Lucy wants to come on and suggest any, or other members of the team would like to. But Ruth, the question is, are there good short activities other than the exercise and CO2 one that we can complete in one session to get a measurable change? So I don't know, Lucy, you've jumped on. Would you like to suggest some activities that they might like to do?
Yeah, thank you, Sarah. The other one that springs to my mind is the CO2 levels of an empty classroom one. So that involves everybody leaving the room and looking at the unoccupied readings. So there's kind of some instructions for having an informed discussion while you walk around the school, while you wait for the changes to happen in the classroom. That's a nice one within a session. And then Henry might like to talk about maybe breathing on the monitor, which is not an official activity, but it's nice and responsive.
Yeah, I mean, my one, if I can't, we've produced so many activities and we've considered so many more. I don't know if we ever did an activity that involved opening an orange near the monitor. I think we discuss it in the website text, but we didn't dedicate an activity to it. That's a good one. If you open an orange near a monitor, you'll see, you can obviously smell the sort of citric acids and aromatics that the orange gives off, and that will be measured by your TVOC measurement. So you will see a spike in that regard. I'd hope that some kids would be interested to do the sort of describe your room activities, and they can all independently do that about the same room. And that's really interesting data for us to see, how children's opinions and records of the same room differ from one to another.
Thanks, Henry. And linked question, which I might start off with answering, but if anyone else wants to chip in, you are very welcome. From the same school is, can these be used for environmental systems and societies, which is an international baccalaureate subject? And I think absolutely. So there's a big data download section on the SAMHE Web App, if you haven't seen that bit yet. So you can either download your whole data set or you can download specific metrics. So I would say download that, use that to analyse the trends. So some of the stuff that Alice and Sam have talked about today might be good starting points for you to explore. So can you detect different patterns on different days of the week, for example? Perhaps you can look at times of the year. So when traffic outside might be busier or less busy, which are things that it might be worth having a bit of a look at. The other activity that I want to kind of signpost to you is the data detectives activity. And so this is a really great activity that we as a team were really excited about and spent a lot of time on developing. So this allows you to explore the trends in your data. So are there particular patterns that you can see? Can you detect, for example, when cleaning staff are coming into the school, when particular lessons are taking place, those kind of things. So I would urge you to have a look at those, because I think that those are really great for that kind of independent project work that you're thinking about there.
Sarah?
Yeah.
There's a question right at the top. Someone asked the question, they were wondering which of our findings have been a surprise to us. And so I'm going to pass this off to Alice and Sam in turn. I guess I would say one thing first, and that is, thanks to the SAMHE schools, we're really creating the broadest national record of school air quality that there is. So even though some of the results might have been sort of obvious and expected, for a lot of the results, you know, the SAMHE dataset is the first time we're robustly able to evidence them at national scale, and that makes a difference to people like government in terms of their policy. So now I should defer to Sam first, and ask you sort of, are there any results you'd like to highlight that you found a surprise?
Yeah, I think we knew weather was going to be quite an important one. Like, we knew temperature was obviously influences people's ventilation behaviours. I think we're a bit surprised at just how strong that link is. Like, you can quite clearly see the number of schools on any given day in the country correlates really, really closely with the average outdoor temperature that day. What I think is quite interesting about that is it doesn't then line up that schools which are in colder environments generally don't necessarily have poorer ventilation. So we can see that actually schools in colder environments, you know, far up north and stuff, generally have adapted reasonably well in terms of their ventilation behavior. Maybe they've got better insulation. So you don't necessarily see them being more poorly ventilated than warmer schools. But if it's a surprisingly cold day for any given school in any location, you expect its CO2 level to be higher.
Thank you, Sam. Alice?
I'd say probably the most surprising result is that we've seen these national trends. So the data we looked at in this presentation today averaged across many SAMHE schools across the nation and many weather stations across the nation. And we're still seeing the schools data and outdoor data very closely linked. And previous, or people who are in the particulate matter outdoor research space tend to think of particulate matter as locally generated or regionally generated, and the fact we see these national trends is very interesting. And we see some big weather events occurring that occur across the nation, and it's really interesting to see that lots of SAMHE schools are affected by it.
I'm going to move on to a bit of a technical question about how the monitors actually work now, because we've had a couple come in. So one question asks, how does the particulate matter and the CO2 actually get monitored? Like, how does the monitor this? And then another question from somebody else, which is, how are the TVOX how are the TVOX readings generated by the monitor? And then linked to the TVOX, is there any guidance around levels and duration of exposure in schools? So I think the short answer to that is No, there isn't guidance. But Henry, do you want to say something about how the monitors actually work?
Yes, I can. So, you know, this isn't my primary area of expertise, but so the monitor contains a number of sensors, it relies on, for some metrics, it relies on compensation between other measurements. The first one I think that I can speak to is, so the total volatile organic compounds. I think it's a broad spectrum electrochemical sensor. And so it's able to pick up a massive range of species, you know, nearly all volatile organic compounds that you might expect to encounter, but it's unable to differentiate between them, and it reacts more strongly to the same concentration of different organic compounds. And so because of that, those measurements are very hard to interpret. The sensor technology is relatively cheap, so you find them in lots of sensors. In fact, very cheap carbon dioxide sensors use total volatile organic compounds to infer carbon dioxide, and that's a very unreliable thing to do, which is why we do not do it. In fact, we have an entirely independent carbon dioxide sensor which uses non-dispersive infrared technologies. So it uses infrared wavelength light to measure the actual concentration of carbon dioxide molecules in the air that's passing over the sensor. The sensors are all designed, which is why you need to stand them on the feet, or they need to be standing up at least. They have an airflow that goes up through the back of them. And then the last one to talk about is the particulate matter sensor. It uses what's called optical particle counters. So that's using light again to bounce off small particles, and then you know, infer what the concentration of particles are. That's an example where you have to compensate for the amount of relative humidity, because relative humidity can, you know, can manifest as small particles. So yeah, this is a whole wing of science in of its own right, but hopefully those terminologies, if you want to look them up, the CO2 is non-dispersive infrared, and the particle measurements come from optical particle trackers.
Thanks,
Optical
Henry.
particle counters.
Particle counters, yeah, it's complicated, but I think you did a good explanation of the way those different things measure. And did you want to say anything about guidance and levels of TVOX exposure in schools? Oh
no, I mean, I tried to cover that by saying it's very, very hard to make any inference from TVOX. I mean, because a lot of TVOX come from indoor sources, it can be sometimes used as a proxy for poor ventilation, but it's much, much better to use carbon dioxide in that context rather than TVOX.
Okay, thanks, Henry. I noticed a comment, what do you mean by standing up on its feet? Mine has been resting on a desk, lights facing upwards. So your monitor should be standing up, like, if you imagine your monitor is shaped like this, square like this, it should be standing up like that, not down like this. Yes. I hope that makes sense. So it should be up like this. Some have come with a little set of feet in the box, which you can just clip onto it. I think we've got a nice little video which shows you about how to clip the feet on, which we can put the link into the chat screen for as well. And that just helps the airflow.
If you don't have the feet, the monitor will stand up just on its own.
Yeah.
And we've done tests. It works absolutely fine without the feet.
Mine is standing up in the kitchen just over here without any feet perfectly well. So yeah, that's completely fine. So we have another question here, which is ventilation is the most important factor. Are there other long-term solutions that have been discussed or are possible to help with air quality in classrooms? And which of our panelists would like to take that question?
I'll mention something.
Go for it, Sam.
One thing that we have looked at sort of in the past is HEPA filters, in classroom HEPA filters in sort of self-contained units that just push air through, and those have been, we've seen they've been really effective in reducing the amount of particulate matter. We've also got a paper, well, impending paper in which we've found some evidence that these HEPA filters during the pandemic were quite effective for reducing the amount of absenteeism, so reducing the amount of airborne illness in classrooms, which is quite a big effect.
Thanks, Sam. And it might also be worth saying that we've got a collaboration with Hertfordshire County Council at the moment, where we are putting, they're putting HEPA filters into each classroom in 30 schools, and we're also putting monitors into those classrooms as well, so that we can actually see the effects of those HEPA filters on the particulate matter. So it'll be really interesting to see the findings from that. And those of you who are signed up for our newsletter will be able to see the results of that when it comes out. I need to wrap us up now. So if there are key questions that you haven't asked yet, pop them into the Q&A function very quickly, and we will see what we can do about trying to answer those. I need to make sure that we all finish on time. Let's just see if there are any last final ones that we can answer very quickly. I think we've done a pretty good job of answering these. I guess just to say thank you so much, everybody, for coming along today, for asking such fantastic questions. Lucy has been busy away putting in the chat screen some links to some of the activities that you can do in the web app. As I said earlier, please keep your monitors on as much as you possibly can. They cost virtually nothing to run in terms of energy usage, and will give you really great data that you and your pupils can analyse when you come back from the school holidays. So I don't think I have anything else to say other than thank you so much for coming along today. Keep up to date with what's going on via our website and our newsletter. Keep those monitors turned on so we keep getting your data, and keep taking part in our activities. If you, as Victoria's just popped into the chat screen, if any of you've been watching the webinar together with your pupils, we would love to know. Get in touch with us. We'd love to hear how you're using SAMHE in your classrooms. And thank you so much, everybody. And we will say goodbye. Have a lovely evening.
Thank you. Bye-bye.
Thanks. Bye.
Thank you.